Hello, this is Andrew Dolan. In this video we're going to be talking about how to take a part from CREO software and export it as a DXF file, then import that into the Carbide Create software in order to generate toolpaths so that we can cut it out on our CNC router. Let's get into the details on how we can do this. Here's a part that I'm using as an example for this video. And you guys can see it's 1/4 inch thick material. I think it's roughly like 4 inches by 8 inches, something like that. And when designing parts for the CNC router, keep in mind the radiuses that we might be limited to. For the most part, in the lab we have cutters that are 1/8 inch diameter and 1/4 inch diameter. So a radius of 1/8 of an inch is appropriate here. And if we have features that are smaller than 1/8 of an inch, 0.125, we're probably not going to be able to cut them out unless we purchase additional smaller cutters. So it's possible, but let's constrain our designs to, radiuses of 1/8 inch, radiuses of a 1/16 of an inch or smaller. So these are 0.1875 holes in this example for a number 8 screw. So once you've completed your design here to create a DXF file, which stands for Direct Exchange something or other, what we do is go into a drawing file. This is the default C-size drawing file that CREO created for us, and we only need that top view. So I'm going to get rid of these extra views that are not needed, and then this view here, it's important that we scale it in a 1:1 scale. So go ahead and change your scale size here so that it's at 1:1. And then we don't need all this extra paper space that's floating around here. So we go into your sheet setup, and instead of using a C-size sheet, just go to the custom size, and we can shrink this so that it's a little bit bigger than the stock that we're aiming to cut out here. So I'm going to go with a width of 12 inches and a height of 6 inches. We'll see how this looks in a moment. All right, then I can take my part and be able to move that around. So I guess I have to right click on this, unlock that view movement so that I can scoot the part around. All right, that looks great. Now we also don't need to have this border that's created in CREO for this. It's nice to have it to get it sized right so that we can have our geometry inside of that 6 by 12 inch or whatever your size is. So when you go back to your sheet setup here and then disable this little show format, and that square goes away, and we're left with just our geometry that we're interested in. So I'm going to hit File, Save, and then go File, Save As. And this is where we can export a DXF file. So basically we're saving this as a DXF. Find it from the settings here, DXF, it'll throw it in your working directory, and we're good to go. So this is saying as a golfbot.dxf file, and I should play around with this a little bit more. We'll see some of the limitations when we get into it, but I'm just going to hit the standard default settings here and go ahead and export it, so hit OK. Next step is to open up that file in Carbide Create. Now, one thing I wanted to mention, that you can download and install the Carbide Create software for free. Just go to Carbide Create, and what we're looking for is this free 2D version, and you can have that on your personal computers. It's a free software for you to use. So once we have that, we need to open up our file, and this Carbide Create will open up those DXF files. So I can go into the golfbot.dxf file here, and it opens up, and we should be all set. Now notice some of the geometries are a little bit different. The grid that's shown here, we can go to our setup icon and change the size of the part. So our width is 12 and the height is 6, And it can be much bigger than that, but that's just fine. It seems to match then. So the origin point, the corner that was selected in our CREO software for where the paper border edge was, that's where this origin point is. And that's perfect. It gives us a little bit of room to cut out and whatnot. So once that's been done, we want to select some of these things. And if you recall from CREO, you need to have enclosed shapes, and somehow I should mess with the DXF settings a little bit more, see if I can fix this. But we may need to group multiple things or join some vectors. So as an example, this is an image that I want to have a contour cut on, or cut that image or those components out. So after highlighting those, and to do that, individually they might be just a couple of segments. So I'm holding down the Shift key or Control key. Which one is it here? Yeah, it's the Shift key to highlight multiple segments, get them highlighted together. And then we'd like to join the vectors. So there's a little icon there that I clicked on to join those vectors. And now if I hit Escape and deselect that and reselect, it joins all those vectors together. So something I've had to deal with on our parts here is to join vectors. So let's try this guy as well. See, it highlighted that, but it didn't grab everything. So again, hitting Shift key, I can multi-select a few things and join those vectors. And there, once again, now when I click on that, it highlights that as one joined group. So probably have to do that on a few of these, and hitting join vectors. There we go. I'm going to do a similar thing on this. Join the vectors. Okay, so if we wanted to cut this out, then we just use our standard patterns and whatnot. So if I click on this particular feature, the outside, I want to contour cut that, I'd go to my Toolpaths and hit contour, use the current selection, and what size bit are we going to be using to cut this out. I'm going to opt to go in here and change it up so that we are going to use a Nomad 1/4 inch end mill. So we have this might be made out of hard plastic, so try to find a material that matches. And we're going to select that number 201 end mill. That looks good. You may want to double check the library of tools, the actual inventory that we have in stock. So I hit select on that. The settings, it's pretty conservative here. Pass per depth is 0.010 of an inch. This is going to take forever in a hard plastic, but these default settings are interesting. You may have to experiment with them. I'm confident we can take a little bit more than that, so I'm going to go down to a 1/16 of an inch, 0.625. Hit OK. And we are good to go. Now let's go to the toolpaths. Right now this is going to the inside, and we want to actually change that up. So the blue line that's shown in the software here is where the center of the tool bit is. So you probably want to go to the outside edge, and that would be a better choice here. And then the depth of cut. So if this is 1/4 inch stock, I would go down to 0.260. So that we've got about 0.010 deeper cut than necessary. We hit OK, and that toolpath is showing now, and we can hit the simulate, show simulation, and we can see what that's going to look like in cutting that out. All right, now if we don't like something after showing that simulation, we can go back in here and edit it. So we can go back and see what's actually going to happen. And change the settings and whatnot. So I don't think it didn't look like it was cutting through, because back to my original design, I don't believe I set this up for the right thickness. So this is showing me it's 12 by 6 inches, and let's change that up to a 1/4 inch thick material. Hit OK. And now back to my toolpaths. If I show a simulation now, you can see that it has cut through. Very good. So hide the simulation and we're good to go. Now, some of these other features, such as these cutouts, if I wanted to highlight a bunch of these and cut those out as pockets. So I can choose the pocket tool here, and with those features selected, use the current selected. And pockets, now we can have them go all the way through, or they could be cut as partially through. You can control the depth of that, but I'm going to cut them through, in this case 260. It still is using that 1/4 inch end mill, and hit OK. And now I can show a simulation on what that would look like as well. Alright, so we've got our pockets cut out and they're going all the way through. There's an ability to rotate this. You'll play around with your mouse buttons to find out how. So I'm done with that, and I'll go back to my design tab here. Now these smaller features, these holes, if I wanted to have a bunch of those all cut out and treated as one group, I can select them all here individually and then go ahead and group them together. So there's an option here. There we go, group vectors. So if I click on that, and I've highlighted all those holes, now when I click on one of them, it highlights and treats them as a group entity, which is useful. So now I'm going to go to my toolpaths, and if I attempted to use a 1/4 inch cutter to cut those out, well, the holes are smaller than that, so it's not going to work. So what I would choose to do here is, again, probably treat them as a pocket and use the current selection. Now in this case, the 1/4 inch is not going to work, so I'm going to edit this, select tool, and we'll go into our hard plastics here. And where'd we go? Hard plastics, end mills, and I'm going to be looking for an 1/8 inch end mill. That should be good to go. Select that. And again, these are real conservative. Now you've got a smaller cutter, so it's advisable to go with a general rule for woodworking. If it's a 1/4 inch cutter, you can probably take half of that for your depth per pass. And in this case, I'm going to go with a conservative, probably 40 thousandths, because it's a pretty small bit and we don't want to risk breaking it. And we've got those selected. In this case, again, I'm going to go to 0.260, so it's going to cut all the way through. And hit OK. And show the simulation. See what this actually looks like. So you've got all those holes cut out. We can see each of the tool paths here. That looks great. Now note that this last pocket toolpath is done with a different diameter cutter, and it shows up here with that. So generally I would have us export these as 3 separate files, I'm sorry, 1 file per cutter if you're using a 1/4 inch end mill. On the contour path, the first one, and the pocket, they can be exported together as one tool path, but because we've got a tool change in here, we cannot export the 1/8 inch as the same one. So we'll export them as separate files. I'll show you how to do that in a minute, but we still have a little bit more design left in here. This golf bot, that text over there, I'm going to highlight this and group that together as well, because you can see if I'm clicking on the letter G, and it treats those as a group, but highlight them and group those vectors together. So now if I click on one, it highlights the entire unit. And this is just going to be an engraving that I would put onto it. So I'll go to my toolpaths, and this would be a V-carve variety. Use the current selection, and this is already set up for a number 301V bit. That should be good to go. The depth on that, 0.1, I guess I'm okay with that. It doesn't need to be very deep. Hit OK. And we can show the simulation what this is going to look like as well. It should just be an engraved text on the material. I have a little problem remembering how to manipulate this. There we go. So it's evidently a a right click hold to kind of pan around, and scroll wheel to zoom, and then a left click will get you to be able to kind of rotate around in 3D space. So that's showing the GolfBot text there, that toolpath. Very good. So some of these, like I'm looking at the times, this one's 41 minutes for this pocket toolpath. That seems excessive, so I wonder what happened there. Let's double click on that, and maybe it was the depth of cut per pass here. Oh, that's back to 10,000s. That's going to have to take multiple depths, so that would take forever. Just watch those toolpath times, and here I'm going to change that to 0.0625. And that's good to go. Okay, so hitting OK on that, then going back. Now you can see it's a much shorter toolpath. This is going to take just a few minutes to cut each of these out. So as I'd mentioned, what we want to do is export these toolpaths based on what type of cutter that we're using. So in this case, the first outside cut contour and this pocket. So if I select those only, and to do that we can basically go in here and disable some of these other toolpaths by right clicking on them. So now I've got the outside contour and this. That's excellent. I want to save that as a toolpath with only those two enabled. Save toolpath, and we're going to hit Save Toolpaths as a new C2D file. And I'm going to give this a little bit different name. I'm going to call it the GolfBot, and I'm going to put it in as 1/4 inch end mill. Okay, something like that, just as an indicator of what we're cutting out here. So that's its own file we'd pull up, cut out with that 1/4 inch end mill. And now let's go about creating files for the other ones. So I'm going to disable the pockets now. And then let's say this other pocket here with the just those 3/8 or 3/16 inch holes, I'm going to make that as its own because it has its own 1/8 inch end mill that we're going to be using. So save a toolpath here, a new C2D file here. And in this case, I'm going to highlight that, but I'm going to change it so that it's GolfBot 1/8 inch end mill. Save. That looks great. And then disable this one and enable the V-carve. So it's just going to be that feature that we're cutting out. And again, save toolpaths as a separate file. And I can click on this, but instead of the end mill version, this is going to be GolfBot. I'm just going to call it V, so I know which tools to load up for those. That's looking good. And from there, I guess I would have to run it on the machine. I don't have the Carbide Motion software installed on here, but that's how you guys can grab your files from CREO, export them as a DXF file, and then get in and set up your toolpaths. And just be real careful about how you set up those toolpaths, and only combine your toolpaths into the same files if they're using the same cutter. So in this case, we use 1/4 inch cutter for a couple of them, and then we save that as its own toolpath file. Then we can get in there, do a tool change, and load up the next cutter, which might be an 1/8 inch cutter in this case. Save that as its own toolpath and run that one separately. And then do it again if we have a V-carve in there, and say just enable that one only, save it as its own toolpath, and run it by itself. So this is a bit painful, admittedly, but we don't have a tool changer on the machine. So for each one of those setups, we have to do a tool change manually, and this is a way to keep them all separate and running individually. So there you go. There's a crash course in how to get your files from CREO exported as a DXF, bring them into the Carbide Create software, and run it from there, creating your individual toolpaths based on the diameter. So good luck to you in your projects, and if you have questions, please flag us down if you're in the lab with us, and enjoy. We'll see you guys next time.